In a single replacement reaction, a metal atom replaces a metal atom in a compound, or a nonmetal atom replaces a nonmetal in a compound. Also note that these compounds are ionic. They must contain a metal and a nonmetal. So the basic formula is this. So we have our compound A, B. We react it with a metal. And then that metal, let's say that A and B are both metals, they'll replace each other. And we'll end up with Cb plus A. Here's an actual example. So let's say we have copper 2 chloride, and that's going to react with lithium metal, and we'll end up with lithium chloride plus copper metal. And as always, we have to balance this. Notice that the two metals, copper and lithium, switched places. The other thing that I need to make sure I do when I write what my compound is here, I have to make sure my charges balance. So I know that lithium is going to replace copper. So it's going to become part of an ionic compound. Lithium has a +1 charge, and I know that chloride, Cl, has a -1 charge. I write out the multiples. The lowest common multiple is 1, so I know I need 1 lithium and 1 chloride in my compound. Let's try another example, and this time we will react. Let's say nickel 2 oxide plus sodium, and let's see what that gives us. Well, we know that the two metals are going to replace each other, so sodium and nickel swap places. We know the element that comes out is nickel. Nickel gets pushed out. And now we need to figure out the compound. So we have sodium ions, which have a +1 charge. And we have the oxide, which has a -2 charge. So we write out our common multiples. And we see that our compound must be Na2O. Once we do that, now we can balance. So we need 2 sodiums and 1 of everything else, and we are done. The non-metal example would be something like sodium chloride plus fluorine, and here we have a non-metal going to replace a non-metal. So we know that chlorine gets pushed out, and chlorine is diatomic, so when it's alone it must have the 2. Also, we have to make our ionic compound. Our ionic compound, the sodium stays where it is. So sodium has a +1 charge, and we know fluoride is a -1 charge. Least common multiple is 1, so the compound is sodium fluoride. And we would have to balance. And we're done. So nonmetals replace nonmetals, metals replace metals. So how do you recognize whether a single replacement reaction will occur? Well, the first part is we have an ionic compound reacting with an element. And this could be a metal or a nonmetal, but we have one compound and one element reacting. If we have that, the next thing we have to do is check the activity series. Now, what's an activity series? I haven't talked about anything like this in the examples before, and this is because I was checking this off to the side. But now it's your turn to see what the activity series actually is. So this is an activity series, and this is from oosites.com. And we have two series. We have the metal activity series, and we have the halogens or nonmetal activity series. And the way we use this is that things at the top of the chart are the most reactive. So lithium is going to be the most reactive of the metals. And at the bottom of the chart, we have the elements that are least reactive. So gold would be the least reactive metal. This is actually why gold is often used in jewelry, because it doesn't react very easily. A lithium piece of jewelry would be rather useless, because as soon as it hit oxygen or hit water, it would instantly react and you would have a problem. So, most reactive on the top, least reactive on the bottom. Same thing for the halogens. Fluorine is the most reactive halogen, iodine is the least reactive halogen. And the way that we use this activity series is elements can only replace another element in a compound if the element that is in the compound is less reactive or below it on the activity series. Let's look at an example and see if this rule applies. So the first one we're going to look at is lithium chloride plus gold. Lithium chloride plus gold. So we first check, do we have an ionic compound with an element? So we have an ionic compound, metal and a nonmetal, and we have an element. Good. So we know a single replacement reaction could occur. Now we have to check the activity series. Will gold replace lithium? Remember that whatever element is going to come in, replace the one that's already there, must be more reactive. So we look at our activity series, and we find lithium, and we find gold. Well, gold is less reactive than lithium. We can think of this as gold, because it's less reactive, is not strong enough to push lithium out of the way. So because gold is below lithium on the table, this reaction will not happen. Now instead, if we had gold 1 chloride and reacted that with lithium, Well, let's see if this reaction would happen. So we have an ionic compound with an element, good. Now, will lithium be reactive enough to replace gold? Well, lithium is above gold, meaning it's more reactive, and if the element is more reactive than the one in the compound, the reaction will occur. So in this case, the reaction will happen. Lithium will replace the gold, so we end up with lithium chloride plus gold metal. And we should always actually have states. So gold 1 chloride would be aqueous, lithium would be solid, lithium chloride would be aqueous, and gold would be solid. We'll talk more about how we determine whether something is aqueous or not when we do double displacement reactions, but just know that most single replacement reactions occur when we have a soluble ionic compound, so it's aqueous, dissolved in water, and the metal that we start with is solid, and when we push the other metal out, that metal then becomes the solid. So the big important thing here is that the metal is always going to be solid when it's not in the compound.